Good morning all. This is Kumari, Associate Professor from Department of Computer Science and Engineering, Excel Engineering College. I am very glad to invite all the participants for National Level Online Faculty Development Program on Blockchain Technology, Future of Cybersecurity. Now, I would like to welcome Dr. S. Sridhar, Professor and Head, Department of Computer Science and Engineering, Excel Engineering College, to give welcome address. Sir, please.
Yeah. So, very good morning to all. So, it's my pleasure to welcome you all to the inaugural function of ACT ATAL sponsored 5 days online FDP on blockchain technology, future of cybersecurity. From 18th January 2021 to 22nd January 2021. So it is organized by Department of Computer Science and Engineering, Excel Engineering College, Namakkal District, Tamil Nadu. This FDP is create a platform for discussion on theory and progress, development, deployment, and practical usage of blockchain technologies with respect to cybersecurity. First of all, I would like to welcome the chief guest of today's function, Dr. Rajiv Halder, the professor IIT Patna. So we are really thankful to him for taking the time out of his busy schedule to attend the function. I welcome you, sir. Next, I would like to extend my gratitude to our beloved principal, Excel Engineering College, and Executive Director, Excel Group of Institution, Dr. K. Boman Raja, who are always motivating us to organize various activities under his dynamic leadership, various online activities and events being organized. I welcome you, sir. The next, I welcome our Director of Administration, Dr. R. Nalusamy, for always extend his support and help in achieving our heights. Next, I feel grateful to welcome our Director, IRRP Excel Group Institution, Dr. D. Devagumar, who are great guidance for applying various funding schemes. So once again, I welcome you, sir. And I welcome the participants from the various institutions across the India who are all set to make this FDP as grand success. Thank you, Ananda.
Yeah.
Thank you, sir. Now I would like to invite Dr. K. Bomanaraja, Principal, Excel Engineering College, Executive Director, Excel Technical Campus, to give presidential address. Please, sir.
Good morning to all. Very happy to join this session, which has been organized by Department of Computer Science and Engineering, wherein they are organizing an online faculty development program on blockchain technology, particularly future security. I really congratulate the effort taken by the department of Sridhar, and they could able to a lot of online programs for the benefit of faculty and its students during this pandemic for the period of 8 lot of programs there. So at this time, let me join our chairman and vice chairman in welcome our chief guest today, Dr. Raju Halder, Professor, Department of Computer Science, IIT Patna, whose experience will really benefit our participants, getting some good knowledge about this recent technology, blockchain and even cyber security point of view. So really, it's a kind of platform what we all of us has got during this period, where we can able to engage through online platforms to get abreast ourselves in the recent developments which are happening across the world. So instead of traveling a lot, instead of sitting in a place, it's a kind of opportunity what we all of us being there in our place, sitting comfortably and listening to the lectures given by the experts. It's a kind of new scenario what we all of us has got, which is happening everywhere across the globe, where sharing of information by the eminent experts made very simple and easy. Otherwise, getting an appointment, traveling a lot, traveling a long distance, and accommodating themselves in a fine place. It's all a kind of tedious job in their busy schedules they have to arrange. Otherwise, now we could able to get such a wonderful experts today. The Raju Halder, who is from Patna, has kindly accepted to share his knowledge and experience with all of us. Like this, there are a lot of good team of people, lot of good people are there, eminent personalities are there to share their information to everybody. So uh, as everybody told, and there are a lot of good number of participants today, nearly 70 to 75 people are attending. So all of us has to listen to the lectures given by the experts today, try to learn much in these technologies which are coming up, so that we can have some good exposure, wherein our students will be get benefit out of that. As a faculty, if you are attending, in turn you can improve yourself in the particular area and give this knowledge to the students. If students are attending, take some good project, they can take value addition, some extra courses in technology, so that they can find some good placement. For any placement, of course, they can do a lot of development also, contribute for this particular technology. We are talking about some few quite good number of technology: block science, cyber security, IoT, artificial intelligence, data analytics, supply chain management, like that. There are nearly 7 to 8 important technologies that are, so having some idea on this technology is very important now. So right opportunity that Department of Computer Science has given to all of us to be participating in this program. Very good speaker is there, and as a participant, listen to them and gather a lot of information which is happening from today on. Opportunity that we are all of us. So once again, I join hands with everybody, with my management team of faculty members and students, in welcoming our guest today, Dr. Ravi. So thanks for joining us, Professor. Joining with us, Professor, and thank you so much. Over to organizer and MOC.
Thank you, sir. Now I would like to invite Dr. D. Devakumar, Director, IRRP, Excel Group Institution, to give felicitation address. Please, sir.
Then there any technical difficulty? Devakumar, Professor Devakumar.
Sir, am I audible?
Yeah, of course, madam. Your voice is audible, but Professor Devakumar voice is not audible. I don't know whether he's communicating with us.
Sir, is audible now?
Yes, sir. Yes, sir.
Yeah, now it is okay.
A very good morning to all of you. It's happy to note that.
Voice is breaking, sir.
Very good morning to all of you. It's happy to note that Department of Computer Science and Engineering has organized AICTE ATAL sponsored national level online faculty development program on blockchain technology, future of cyber security. And my special thanks to Dr. Raju Halter, Professor, Department of Computer Science, IIT Patna, was considered to be a chief guest of the day. Management of Excel Group Institution, and Dr. K. Bommanaraja, the Executive Director, Dr. R. Nalluswamy, Director Administration, and Director S. Sridhar, the head of the department, and faculty members, and the student friends, I think those are there. And this is the faculty development program. So wherein we, as told by Dr. Bhavana Raja, enriching the knowledge in the place where we are is a high advantage for all of us. And see that we are highly developed our knowledge. Enriching our knowledge is more important. So that way, this program will give more inputs and knowledge to everybody. And appreciations to all team members, faculty members, HOD for organizing this 5 days program. And Dr. Raju sir, I'm very happy that you are here from IIT Patna. We are Excel Group Institution is having a close association with Patna, I mean Bihar. We have 100+ students studying in our campus. So I think it is a right time that you are here, and your program and your motivation will help us, our faculty as well as the students that an expert and or the technical expert from IIT Patna is addressing our faculty. That will be a great boon and support for us to develop ourselves. A special thanks to you, sir, for accepting our invitation, and all the best for all of you. Thank you, sir. Thank you all the best.
Thank you, sir. Now it's the time to introduce our chief guest, Dr. Raju Halder. It's my privilege to introduce the chief guest of the program, Blockchain Technology Future of Cybersecurity, Dr. Raju Halder, Professor, Department of Computer Science and Engineering, IIT Patna. Dr. Halder completed his PhD in Computer Science from San Foscari University of Venice, Italy. Dr. Halder completed his MTech from University of Calcutta. He served as postdoctoral researcher with Maxwell University, Australia. He also worked in robotics team at HasLab, University of Minho, Portugal. He also worked as a system engineer with IBM India. His area of research interest includes formal methods, blockchain and smart contracts, program analysis and verification, information system security, etc. Please, sir.
Thank you. So I think first I can share my screen, right? And then.
சொல்லுங்க இப்போ உங்க கூட டிஸ்கஸ் பண்றது ஜெனரலா தான் டிஸ்கஸ் பண்ணணும் இல்லையா? ஆமா சார். இப்போ ரெண்டு பேர் இருக்கிறதுனால
6 years experience at Excel sir.
ஆமா ஆமா.
And 10 years in other colleges.
Total years 15 years sir.
Well, so I think the screen is visible, right?
Last year complete பண்ணது. Yeah, 2019. Yes sir. Yes sir, visible.
Oh, okay. Well, so very good morning to all of you. So Honorable Director, Excel Engineering College, Honorable Principals, Honorable Administration Directors, Department of Computer Science and Engineering, Excel Engineering College, all the participants, faculty members and students. So good morning. So first of all, thank you for inviting me to this program for delivering a lecture. So I'm really honored to share my experience on this blockchain technology with all of you. So, and of course, I would like to thank that AICT ATAL program. That means for their large drive for FDPs, online FDPs all over the world, India. Last 1 year, I find so many FDPs are going on, and this is really a good opportunity for participants, for all of us to share knowledge with each other, and especially they are looking after, I mean, the special kind of thrust areas. I mean, blockchain, AI, machine learning, which I feel that all faculty members, students, and as research community, we must have to learn. So in this course, of course, the title of the course that in this course, the blockchain technology with the cybersecurity perspective will be covered. So in the first session that I'm going to take, of course, I'll cover the introductory part of blockchain technology, and I'll give some overview that why blockchain technology is so important at this point to adopt. Few example I can highlight. That today we are putting our the money, we are keeping all those money in banks. We are using credit cards. In all of the cases, we find that there are certain kind of risk. For example, recently you have observed that some news we have found in newspaper about Punjab Maharashtra Bank, that they are unable to pay the money back to their customers. So this kind of certain risks are there. So the question arises that when we have our own money, when we are keeping those money in the third party banks, so why certain risks are there? Why we are going for that kind of risk? So can we not have this kind of situations where we do not have any kind of third parties? We do not have to be dependent on any kind of third parties, and we have our own money and we can do whatever we want. So what we need, just we need some internet connections, some device, and then we can deal with our own money. So we don't have to be dependent on any third parties, untrusted third parties. So this kind of situations, if we can bring it in our life, of course you can understand that our life will be completely smart. So when government is talking about smart cities, they are moving towards smart city projects. So of course, I am quite sure that without blockchain technology, our life won't be smart. And I am sure that I observed, I find some videos where I find that central government, state governments, they already have taken a lot of initiatives adopting this blockchain technology in their in various scenarios. So I'm sure that within 5 or 10 years we'll find the good flavor of these technologies, and our life around will be very, very very smart, and so hassle-free life we can deal with. So another example I can just mention briefly here, that for example, that there are so many schemes, government projects going on, and lot of money are being spent, are being invested by governments. But what is happening, although the money is flowing through the proper channel, but finally, whenever you can find at the low level, whenever the actual project is being executed, maybe certain cases we can observe that the quality of the project, the money spent for that project may not be up to the mark. But here, because of lack of transparency, you do not know, as common people, we do not know why this kind of things happens. Where is the money? So when we adopt this blockchain technology in all those kind of systems, so of course it will bring a lot of transparency in the systems, and we can easily get that where the money, how much money is being invested. So every details we can get based on the blockchain technology. So therefore you can understand this technology will make our life completely smart. So with this short note, I do not take much time to give this all this information at this point, but of course many things, many details I'll cover in the lecture. So again, I would like to thank our that Excel Engineering College for giving me opportunity to share this experience with all of the participants. So thank you once again.
Hello.
So now I think I can move to my actual technical content. Yeah.
Same.
So is it visible? That slide?
Size பாத்தீங்களா காமிச்சாங்களா இல்ல அது ரீயூஸ் மல்டி யூஸ் எல்லாம் சொன்னால அந்த இதெல்லாம் once
hello
single use தானா
So can I start? Is it visible?
Yes, sir.
Yes, sir.
Okay. Okay. So let me start with today's first session. So that I just mentioned just now, that today, in the age of digitalization, we have lot of things that we have put in the internet in the digital form. Even you know that any kind of videos, any kind of images, any kind of so everything we have put in the form of digits, and we have put it in the internet. Even we can also put relationship. So for example, in case of Facebook, in case of Twitter, we know that these are the social networks, social platform where we can make our friends, although we do not know each other, we do not have any relation, but suddenly we can create our relation in the digital form, and we can put in the form of in the digital form in Facebook, in Twitter, in other social networks. So therefore the question is that when everything we are moving towards digitalization, we are putting everything in the form of digits on the internet, why not money? So what happens whenever we do some kind of transactions using credit card or using bank? What happens that suppose I want to purchase something from you. So what I do, I will give my credit card information to you. So you have to contact my credit card company and you will get the payment. And later, maybe after 30 days or 50 days, I have to pay that money back to the credit card company. So you can understand that credit card company is there in between, and I have to be dependent on credit card company. What happens when we purchase something using bank transactions? So what I have to give? I have to give to the bank the order, the request that please pay this money to the seller from my account. And once the bank will receive the request from my side, bank will pay that money to the seller, and then seller will dispatch that product and I'll get the product. So this way, so here you can find that bank is the intermediate party, the third party on which I am dependent. So you can understand that everywhere some kind of third party is there, and you can understand if bank somehow cannot pay me back that money, then it's really a disaster. I can put crore of money in bank account, but suddenly bank can say that no, we cannot pay you back. So therefore, can we remove all those kind of dependency on the third party? Can I have the situation that I will have internet connection, I'll open my computer, I'll connect my computer with the internet, and I'll press the button and my money will be sent to the recipient, transferred to recipient. Therefore, here I do not have to get dependent on any third parties, and my money will be remaining with me completely. So that is the main objective here. Another issue is that, for example, whenever you are sending money from abroad to India, so of course you have to dependent on Western Union or some other third parties where they will help you to transfer your euro or USD in India in INR, but they will also deduct a charge. They will take charge from you, maybe $10 or $15, whatever, depending on the how much money you are transferring. Now, in all those cases, you get dependent on the third party. So can I remove this kind of third parties? So can I make it cross-border transactions without having any third party? So it's my money. I will open the computer, I'll connect it to the internet, and I'll press the button, and it will go anywhere to any recipient all over the world. So there will be no concept of boundary. That was an open question till 2008. That is it possible to create some money in the digital form without having any kind of centralized authority like bank, like Western Union, like a credit card company? But very interestingly, that in 2008, this problem was solved. The first paper that was communicated by Satoshi Nakamoto, and the paper name was Bitcoin, a peer-to-peer electronic cash system. What he has actually proposed in this paper, he has proposed a form of digital form of currency, and the transactions of this digital form of currency will happen without having support of any third parties. There will be no role of credit card company, there will be no role of banks, no third party. And people will hold their digital form of money that is called cryptocurrency, and the name of the cryptocurrency was Bitcoin. Okay, so that Bitcoin people can hold and people can transfer the Bitcoin from one person to another person without having any third party like bank. And in 2009, he has also provided one reference implementation, and he made this implementation, the code, publicly available. And over next 3 years, he has maintained that code also. But suddenly, after 3 years, this person suddenly disappeared. And now people were trying to identify who is that person. And suddenly it was found that Satoshi Nakamoto is not the real name of the person who has introduced this Bitcoin. So he has used some kind of fake name. So what is the reason behind that? Why Satoshi Nakamoto, I mean the actual author, has not given his original name? No one knows that. And now today you can find a lot of people, they are claiming that they are Satoshi Nakamoto. But of course, not yet proved that who is the actual Satoshi Nakamoto. Today, if you visit various websites, you can find more than 5,000 such kind of cryptocurrency are there in the market. So although Bitcoin was the first cryptocurrency, but today you can find more than 5,000. And Bitcoin is at the top. And Ethereum is another cryptocurrency that is in the second position in terms of popularity, in terms of market price. And you know that in last year, 2019 beginning, I have started teaching this course in my institute. So, and that time I searched internet that what is the cost of Bitcoin in market, and that time it was only 3,800 USD per Bitcoin. But today, yesterday, I have just collected this information that yesterday one Bitcoin cost is 34,758 USD. Now you can understand that what is the demand. So this variation of the price in the market completely depends on supply demand. So you can understand the demand, you can understand the popularity, and more people are really dealing with Bitcoin. They are making some kind of transactions using Bitcoin. There are a lot of financial organizations in the world who are really investing a lot of money in the Bitcoin. And there are different vendors also. They are accepting Bitcoins. And more organizations, more vendors, more people, they are joining to accept this Bitcoin, to make transactions using Bitcoin. So all this information you can get in the internet, and many more news you can get about Bitcoin. The countries, those are completely friendly with Bitcoin. Those are Italy, USA, UK, Finland. So there are a lot of countries, they are completely Bitcoin friendly, and they are accepting, they are allowing any kind of Bitcoin transactions. In India, initially Reserve Bank of India proposed to ban the Bitcoin cryptocurrency, but finally Supreme Court has given that the final decision of Supreme Court is that no, ban should not be there. I mean, they have withdrawn the ban on cryptocurrency. Now in India, you can also make any kind of transaction, any kind of selling, purchasing Bitcoin, and this is legal in India also. Now, when we look at Bitcoin or look at other cryptocurrencies like Ethereum, like Cosmos, like there are so many different Bitcoin Cash, there are so many different cryptocurrencies available in the market. But what is the technology behind this Bitcoin? So the technology behind this Bitcoin is called blockchain technology. And this blockchain technology, of course, first introduced by Satoshi Nakamoto. So Bitcoin was the first cryptocurrency, and behind that cryptocurrency, blockchain was the technology. And later, that blockchain technology is being adopted by other cryptocurrencies also. But the interesting thing is that while cryptocurrency can be thought of as one application of blockchain technology, but people have identified so many different applications of these blockchain technologies. For example, IoT security, supply chain, electronic health records, copyright protection, KYC, land registry, smart home, smart agriculture, educational system, certificate sharing, social network, e-voting, e-governance, e-commerce, postal systems, criminal record sharing, asset transfer, and many, many more. Of course, cryptocurrency is one such application. So therefore, you can understand blockchain not only suitable for cryptocurrency, but also suitable for many other applications. And this is not the complete list. You can find so many applications of blockchain technology. And therefore, you can understand blockchain technology is so powerful. And if you look at Gartner, I mean, this is a website where you can find the hype cycle of different technologies. You can understand that there are so many different applications of blockchain technologies. And also, Gartner also predicted that, I mean, listed blockchain technology as one of top 10 technology in 2020. In India, of course, a lot of initiatives, central government, state governments, they have already taken, especially maybe land registry, land records, maybe in case of healthcare, they have already taken a lot of initiatives. And very interesting thing is that, you know, that Telangana announced that they want to become India's blockchain capital. And what they are doing, they are giving subsidy, I mean 20% subsidy if you want to start your blockchain company. So they will give a lot of support. And in 2019, I mean February 7, okay, so yeah, this one I just got maybe last year, that currently in India, of course, 332 blockchain startups are there in India, but of course this number increases, I mean after. So this is quite old data. And so you can understand, so there are a lot of initiatives taken in India also. Now, whenever we talk about blockchain technology, you can find that there could be three different pillars that you have to look into. So one is that, what is blockchain? How the information in the system will be stored? What would be the structure of the data? What would be the data structure? So that we have to think of that, what is the structure of this blockchain where the actual information will be stored. I mean, we have to deal with the data structure. Another part is that since this blockchain technology works in a distributed manner, so we have to have some kind of, you know, distributed algorithm. So consensus algorithm is very crucial, one of crucial distributed algorithms. That's really important to know. So therefore, you have to know about various consensus algorithms working in these distributed settings. And another thing, to achieve security of the data, to achieve security of the systems, you have to have some kind of cryptographic primitives. So these three aspects you have to focus. Now, let's talk about this data structure. What is blockchain? How the information will be stored in the blockchain? So to know that, before we have to move to we have to know a little bit about hashing. So you know that what is hash function? Suppose I have a set of input. The hash function is a function that will map one input from this domain to codomain. So in this case, this input will be of any length. There is no restrictions on the size of the number of inputs or possible lengths of the inputs. It's very big domain. But whenever you apply hash function, it will map every element in this domain to its codomain, but you can understand the codomain size is very small. So here the size is fixed. I mean, every output will have fixed size. For example, 256. So you can understand every output here, every element in this codomain is of length 256. For example, this is one example. So therefore, how many elements can be there? How many elements can be there in this codomain? 2 to the power 256. So this is of fixed length and fixed size, the codomain, but input domain can be of any size and input string can have any length. So now let's give one example of such hash function. So this is one hash function that mot26. Now how that hash function will work? So here you can find that suppose I am taking one input, the input is this. How I can apply this hash function? What I have to take? I have to take the numerical representation of every character and whatever addition up result I get, I will apply the mod operation and finally I get something. And this is the hash value. This is the hash value. What is the beauty of that? So, you know, the property of hash function is that once I know the input, I can compute the hash value, but the reverse is not possible. I mean, you cannot have any inverse function of the hash function. If I give you 15, can you go back to these strings? No, it is infeasible. So therefore, another property is that you know that here, suppose I have two inputs. So for this input, if I apply hash function, I will get something. And for this different input, if I apply hash function, I get also the output hash function, hash value. But when the hash value, I observe that they are same. So it means that this, although the inputs are different, but the output, the hash value can be same. So this is called collision. So the property of hash function is that once I have the hash value, I cannot get back the original input. And second one is that although collision can be there, collision must be there. You see, since this is very large domain and this is very small domain, codomain, so of course collision must be there. Two input can map to the same. But this collision, practically, it's, you know, finding such collision is infeasible. Practically, I'm talking about theoretically, of course, collision must be there, but practically, finding collision is infeasible. And another property is that when I am applying hash function of the input, and this is the hash value, you observe that if there is a small change, I mean v is replaced by u. If v is replaced by u, you can understand there is a significant change in the hash value. So you can understand here. So please let me know if my voice is not clear or you do not understand anything. Please feel free to ask me. Or maybe I can take questions after the session. But at this point, if you find some kind of technical difficulty in communication, so of course, please let me know. Well, so now here you can find that although the input, I have made little change in the input, but there is a significant change in the hash value. So this kind of property is very crucial in blockchain. So let's see now how we can construct the data structures where we can put some kind of different information. So now you already know about pointer. So suppose I have some data in the memory, and this here, if the address of this data block I put it here, this will act as the pointer, right? So pointer is nothing but holding the address of the data. But along with the address, if I put here also the hash value of this one, hash value of this data, so this is called hash pointer. So just what is the difference with pointer? The hash pointer, here not only I will consider the address, but also I will consider the hash of the data inside the target area. So this is called hash pointer. Now, if I make use of hash pointer and I construct this kind of, it looks very similar to linked list, very similar to linked list. But what is the difference with linked list? That here, rather than putting only the address, I will put the hash pointer. I mean hash also I will put here. So what is happening? Suppose this is one block. In the block, I have put the data. And then what I do, the hash value of this data along with the address, I will keep it here. And now, again, I will add some data here. I will create a block. So the hash value of this block along with the address of this block will be kept here. Now the hash value of this block along with the address, I will keep it here. So now this is called blockchain. So you can understand this is nothing but chain of blocks. But here the chain is being constructed by using hash pointer, where the hash value of the target block will be considered. Now, if this is the situation, what is the benefit of considering this hash pointer rather than simple pointer? Anyone? Suppose, what is the benefit? Suppose I want to modify some data. Suppose anyone in the system acting as attacker. So if anyone is acting as attacker, they of course try to modify or temper the data. So if data is being tempered, what will be the problem? Can he be able to temper it, change it? Anyone? Okay.
We have to change the data.
Sorry, your voice is breaking, but anyway, I guess something, yeah, you might be correct. So what is happening actually, that if I change the data, the hash value of this data will be changed. You see in the previous here, if I change the data, the hash value will be changed, right? So therefore here you can find that if I change the data, the hash value will be changed, and if the hash value will be changed, of course this will affect the this information. And if the information is being changed, then the hash value of this block will be changed, and that will affect this place. And if this is being changed, then the hash value of this block will be changed, and this will affect the final root. So therefore you can understand, if you try to modify any portion of the data, the remaining part of the blockchain will get invalid, will become invalid. So no one can alter any particular part of the blockchain. So once you write something in the blockchain, once you store something in the blockchain, it never can be changed. Now, therefore, if this is the blockchain, we can compare this blockchain with the physical form of ledger. So for example, in old days in bank, this kind of physical form of ledger was maintained, and where every page all the transactions will be stored. I mean, for example, your passbook given by State Bank of India. So there you can understand that a number of pages are there, and every time you are putting all this transaction information into the passbook. So can you compare this physical form of ledger with the digital form of ledger? I mean the blockchain? Yes. So every page of your physical form of passbook can be compared with the blocks. So one page in the passbook is equivalent to one block in the blockchain. And you can understand those pages are somehow, there is a binding. So here you can find this can be compared with the chain. I mean, every block will be somehow chained with each other. And here also you can understand that in every page, if you look at the content of the every page, you can find there are some transaction information. So those transaction information will be nothing but data. So in every block there will be data, but along with the transaction information, you have something more also. For example, the page number, right? Page number, chapter number, those kind of things in the page, it is the metadata. Page number, chapter number, title of the page, something. So these are the metadata. So in every block, along with the transaction information or your data, you should have also metadata. So now we are moving from the physical form of ledger to the digital form of ledger. Now let's see how it works. So in this case, what happens when we talk about centralized system, when we talk about decentralized system, when we talk about distributed systems? So in previous case, for example, in your organizations also, for example, it may happen that there is one server, for example, student server, right? Student record is being maintained in that server. So there is only one server, and all students can access that server to get their information. So can we think like that there is only single server and all students sending request, and the server is executing the request and giving back all the response or services to the students. So therefore, this is the centralized system. But what is the problem with centralized system? The problem with centralized system is that if the server fails somehow, then of course, no one will be able to get services. Or another example could be that in your case, of course, the environment is trusted, right? Because you are part of the organization and the organization is taking care of all this. But whenever you go for any unknown kind of, you are asking for services from the unknown server. So of course, this is quite risky. You are relying on the third party and third party is untrusted. So of course, this is question mark. You cannot go for that. Another thing, therefore, what happens in case of Facebook, Google, what happens? Google has deployed not only single server to avoid failure, but they have deployed so many different servers across the globe. So therefore, if one server fails, the people can get service from the another server. So therefore, in Facebook, in Google, you never get experience that kind of failure. Or even if you have experienced that kind of, it's very rare. I mean, very recently you find that Google was, down for the whole day, maybe, but this is very rare. But what happens? As a user, we do not understand that whether there is any failure or not. Of course, there is a failure. There are so many different servers, but it is obvious that some of the servers may fail, but it does not disturb the services. So people can get service from the other servers. But of course, this is decentralized. But of course, you are relying on third party. I mean, whenever we are talking about Google, for example, Google Drive, you are taking the service, cloud service of the Google. So there you are keeping your important documents, you are sharing through Google Drive, you are creating some documents there. But of course, you are believing, I mean, you are dependent on the third party. What will happen if those kind of cloud service provider not trusted? Do you go for, using that service? Of course, no. For example, can any bank use Google Drive for their banking purpose? Of course, no, because there is a trust issue. Sensitive information, they cannot go for third-party cloud service provider. Okay, so therefore, to avoid this kind of trust issue, you can move towards distributed system, where there is no server, no client concept. Everyone are equal. Everyone is equal. I mean, any node, any user here can act as server, can act as client. I mean, any node, not user, any node can act as server as well as can act as also client. So here you can find that equality somehow preserved. Okay. So this is a distributed system. So in blockchain, we always move to this kind of setting, the last distributed setting, where everyone is equal. There is no boss, no servant, no higher authority, no lower authority, all are equal. Okay. But of course, I am not telling that this is the motivation. But of course, in practice, whenever we go for using this technology in any particular application areas, maybe some kind of hierarchical structure we need, and we can go for that. There is no problem with that. But overall, the motivation was that we can remove all kinds of dependency, we can remove all kinds of third parties, and everyone are equal, and they can make all kinds of activities equally. Okay, that was the motivation initially. So now we go for this kind of distributed peer-to-peer network, where every node will be connected with other nodes logically. Okay, so when we talk about blockchain network, you mean that this is nothing but peer-to-peer distributed network. Now, what happens? I'm just giving one, taking one case study that what happens when we talk about Bitcoin. So just taking one Bitcoin as a case study. So in this case, what happens? Suppose this is the Bitcoin network currently going on. There are a lot of nodes connected in a peer-to-peer distributed fashion. Now, suppose you want to join Bitcoin network. Suppose you want to participate Bitcoin network and you want to make some Bitcoin transaction. So what you have to do? There are, so this is you. So there are certain nodes, and those nodes are called seed nodes. Those nodes are called seed nodes. So when any new participant wants to join, then that participant should send a request to the seed node, asking that, okay, I want to join the network. Please give me the nearby addresses. So which are the nearby addresses? 1 and 7. So the nearby addresses will be given back to the participant, and then the participant will send a request to 1 and 7 in a similar fashion, and will ask that I want to join, please give your neighbor's address. So again, 1 will give the neighbor's address 5 and 6, 7 will give the neighbor's address 5 and 2 and 3. So this way, finally, it will be repeated certain times, and then after that, the node will be connected in the peer-to-peer network. So this is the first time you can join to the peer-to-peer network. Now, as I have already mentioned, what is the blockchain? Blockchain is of this form, right? This is the form of blockchain. Now, suppose in this session, I think maybe if there are 70 participants, so suppose 70 participants created a peer-to-peer network, peer-to-peer distributed network. Now, what will happen in this peer-to-peer network? Every participants will have this blockchain copy. I will have this blockchain copy. You also will have blockchain copy. So everyone will have blockchain copy with them in the network. Now the question, okay, we can have blockchain copy with everyone, but how to achieve consistency? I mean, suppose a new block with new information is being added to this blockchain copy. So of course, the same information should also be added to other blockchain copies. How to guarantee that? How to ensure? How the system will, how the technology will ensure that whenever new information in the form of block will be added to a blockchain copy, the same will be added to other blockchain copies, so that information in all the copies should be consistent with respect to each other. It should not happen that some information is being added to this network, this blockchain copy, and some other information is being added to this blockchain copy. So the information in different copies are different. It should not happen. So you have to ensure that information in all blockchain copies are same. So that is the consensus algorithm. So through consensus algorithm in the distributed system, you have to achieve this objective. Okay, so in the course, of course, professors will highlight about the consensus mechanism, how you can achieve this consistency. What is the benefit of having this kind of setting? That I told that everyone in the network will have the blockchain copy with everyone. So what is the benefit? The benefit is that, suppose it's just one very simple example, but in reality it's not so simple. It's really little complex. But just for illustrative purpose, I can give this example. But of course, this slide I have taken from the slide lectures by Dr. Sandeep Chakraborty. Okay, so here what is happening? Suppose initially the blockchain is having just one block, assume, and in that block there is only one information at this point. So suppose Alice has 100 rupees. That is the initial information in the blockchain, and the blockchain copy will be with everyone. Now, suppose Alice wants to transfer some money to Bob, 50 rupees. So of course, this is a new transaction. When new transaction will happen, you can understand that the new transaction will be recorded in the blockchain copies, in all the blockchain copies. And there is no problem, because this transaction is valid transaction, because Alice has enough money. Suppose Bob wants to transfer 30 rupees to Eve. So this is also valid. So this also will be added to every blockchain copy. But how it is happening, I'll tell you later. How this copy is being added to all this, maybe very quickly I will tell you in this lecture. But you can understand there is no issue. Now, but when Alice is trying to send 80 rupees, is it possible? Not possible. Because you can understand, Alice initially had 100 rupees, then Alice has sent 50 rupees to Bob. So Alice has only 50 rupees available. So when Alice will try to send 80 rupees, of course, no one in the network, I mean, you know that what happens when the new transactions will be created. I mean, whenever these new transactions created, Alice will broadcast this transaction information to everyone, and everyone will check that whether this transaction is correct or wrong. So Bob can check it, Jane can check it, Eve can also check it, because they have the whole history, transaction history. So anyone in the network can check whatever Alice is trying to transfer, is it valid? So if it is valid, then it will be accepted by everyone. But it will be accepted by everyone. But when Alice will broadcast this transaction into the network, it will not be accepted by anyone, because Bob can check, okay, Alice does not have 100 rupees. So how Alice can send 80 rupees? I mean, Alice does not have 80 rupees. How Alice can send 80 rupees? So of course, Bob will not accept it. Eve will not accept it. And Jane also will not accept it. So this transaction, since it is invalid, so it will not be accepted by the network. Okay. So this is the idea. This is the motivational factor that I would say that advantage of having this blockchain copy with everyone, and this will make it very transparent and trustful. So now coming to these questions. So the questions is that who will maintain the blockchain? Anyone, can you answer?
Because here everyone is acting as a client and server, right?
No, there is no concept of client, no concept of server, because we are talking about a distributed system. So everyone is equal. So whenever in the Bitcoin, all the participants are there. I mean, in our session, for example, in this course, 70 participants, we have formed the peer-to-peer distributed network. So of course, there is no difference. I mean,
Yeah,
okay,
got
we
it.
all are
Got
same. So in this case, who will maintain the ledger, the blockchain copy? You are right to some extent, yeah.
So everyone has to do that.
Everyone, exactly. So everyone will have the blockchain copy, and everyone will maintain their blockchain copy. All participants. So next question, how that could be maintained? How? So that I will not, maybe very high level, I will mention that part, but in detail it will be covered in the course. That is called consensus mechanism, the distributed consensus algorithm, through which that will be maintained. That means when one block will be added to one blockchain copy, the same block will be added to other blockchain copies also. Okay. Now next question, who will determine the validity of the transactions? For example, in the previous slide, you see that when Alice created this transaction and broadcasted this transaction into the network, no one has accepted this transaction. So because they have checked that this is not valid. But in the previous case, when this transaction happens by Bob, it has been accepted by everyone. So who is going to verify the transactions?
All participants.
All participants, exactly, everyone, because everyone has the blockchain copy. So everyone can verify whatever transactions happening in the network. I mean, whenever I will create a transaction, I have to broadcast. So everyone in the network can check whether my transaction is valid or wrong, because they have their own blockchain copy, and blockchain has, I mean, whole history. This can be done, maybe it won't be covered, because the main motivation of this course is covering cybersecurity aspects. But so there is one language. I mean, I am talking about Bitcoin. For example, if I talk about Bitcoin, there is one language. Whenever a new transaction will happen, I have to write something in that transaction using that language. Okay, so whenever I will create one transaction, I have to write something in the transaction using this Bitcoin script, and that Bitcoin script will help all other participants to verify whether my transaction is correct or wrong. So that is done by Bitcoin script. And now finally, who will create the new Bitcoin? So maybe you will get to know the high level, but detail will be covered in the course, that this is called mining process. So who is going to add, exactly, who is going to add the new block? No, all cannot add block. The block will contain the actual information and block will be added to the blockchain copy. So all are not allowed, or all, I would say that all may not be able to add the block. Only few will be able to add the block. So who can be able to add the block, they will get some kind of reward. Okay. And that is the new cryptocurrency to be created. So when adding the block to the blockchain copy, this is called mining process. Okay. Through the mining process, some Bitcoin, some cryptocurrency will be awarded, and that is the newly creation of the Bitcoin. For example, in case of Bitcoin, I'm talking about. So now let's just briefly go through the working principles of blockchain
Sir, I have
technology.
a question here.
Yes. Yes.
Sir, since it is a distributed system, suppose like we have thousands of nodes are running. So in case one node is updating, one transaction is doing by A. Okay, let's say A. So it's supposed to notify all other nodes, right? So all this process going to be take so much time, right?
Right. But yes.
So
yes.
entire process going to be take a large amount of time to complete this entire process, right?
Right. It will take some time. I mean, I'll talk about that. So
All right.
in case of Bitcoin, it takes around 10 minutes. In case of other cryptocurrency, it may take few seconds. I mean, it's not very. I mean, we can wait for few seconds to get my information included in the blockchain. No problem.
Okay.
So although it looks that it will be very time consuming, but practically it's not actually, because the size of the transaction not so much. I mean, very small. So it's not a problem.
Okay.
Okay, now how blockchain works. So first, what I do, I will open my computer, I'll connect to the internet, and there is the wallet software. You know, the Paytm wallet, Google wallet, there are so many wallets, right? So similarly for Bitcoin, for any kind of cryptocurrency, I should have some wallet software. And the wallet software will help me to create the transaction. And the wallet software will help me to manage the cryptocurrency that I have. Okay, I do not have to do anything manually, so the software will do it. So I have the wallet software in my system that is maintaining my account with my cryptocurrency, how much money I have. And now the wallet will help me to do all the activities. For example, I want to transfer money to XYZ. So I will give the instruction to my wallet, and wallet will create the transaction. And then after the transactions, these transactions will be broadcasted into the network. So everyone will receive the transactions. How the transactions will be created, those are different things. I mean, if I get time, possibly I do not get time. So therefore, I am not going to give the details of the transactions at this point, but you just understand some kind of format is there of the transactions where some kind of information I have to mention. And those information will help others to verify whether the transaction is valid or not valid. Okay. Now, for example, here you can understand this is the broadcasting of the transaction. So this way the transactions will be broadcasted. So I will send my transaction to my neighbors. The neighbor will forward the transactions to their neighbors, and this way it will be flooded into the network. And now, as I told, there are certain few nodes who are kind of, I would say special kind of nodes. You can also be special. I am not saying that any particular node will be special. No, anyone can be special. What you require little more power in the machine. I mean, computation power or memory power, whatever. Some kind of power you should have. Okay, so if you have more power, so you can act as miner. So few nodes are there in the network who are a little bit powerful, so they can act as miner, not all. And then what is the task of miner? The task of miner would be, that whenever I am a part of the network, since all the transactions are broadcasted by everyone, so of course being part of the network, I can listen the transactions over time. You can also listen the transaction. Others can also listen the transactions. So similarly, miners can also listen the transactions. So more transactions coming. So what miner will do, miner will accept a set of transactions which are valid, because anyone can check the validity of the transactions. So miner will consider the transactions which are valid, and using the transactions, it will create the block. And block has also certain, structure. So I am not going in detail what is the structure, but in the block, all the transactions will be stored. I think, yeah, I have the structure. Okay, I can very quickly tell. So these are the transactions that miner has to put in the block. And along with that, miner has to also put some kind of metadata. Metadata means what is the hash of this block? What is the timestamp when the block is being created? And actually the transactions will be stored in the tree form. It's not in sequential form. It will be stored in the tree form, and that is called hash tree or Merkle tree. So you can get the more details about the Merkle tree, that whatever transactions you have to compute the hash value, and whatever hash value you get for these two, again you construct the hash value, and this way you can construct the Merkle tree, and this contains all the transaction. So these will be stored here. And this is the root. The root will be here. Root will be part of the metadata. See, the blue color is metadata, and the red or pink, this is the actual transaction. So it will be part of the root will be part of the metadata. And along with that, some other informations also will be there that is called metadata. So after this creation of the block, now the miner, block creation is very simple, right? This is the structure. I can put every information in this manner. That's very simple. But then miner who has created this block has to do some kind of puzzle solving. So what is the puzzle solving? Let's see. So whatever block the miner has created, miner has to compute the hash value. SHA-256 was one hash function. So miner has to compute the hash value. And whatever hash value miner will get, miner will check that how many zeros are there at the beginning of the hash value. So you can understand, it may happen that miner has created this block, and after computing the hash value of this block, there is no zeros, or there is few number of zeros. But in the protocol, Bitcoin protocol, it is mentioned that you have to achieve this number of maybe for example 100 zeros at the beginning. So when you miner creates this block and miner computes this hash, miner gets that okay, there is no 100 zeros. There are less than 100 zeros. So in this case, what is the possibility? Look at this example. In this case, you can find that this is my information, actual block information. For example, and this is my hash function. If I apply hash function, I cannot have 100 number of zeros, for example. So what I can do, I have to change the input, then I have to compute hash again, and again I have to check, no, still 100 zeros are not there. Then I have to check, change the input, and I have to repeat this process by changing the input. How can I change the input? Some part of the input are fixed, but some part I can vary. So therefore, if I vary this part, I can try again and again, and finally I can be successful. I can have 100 number of zeros at the beginning, so I am successful. So in this example, it is showing that you want to have only 3 zeros at the beginning. So it means that these are the valid hash. Whatever hash value you get after performing computation, the final result should be within these. Others, not valid. So it means that this is my output codomain, right, of the hash function. This is the codomain, because 5 length hash value I can get. 5 length hash value means total 32 possibilities. So any one is the hash value. But I have put some kind of restrictions that only 3 zeros at the beginning should be there. So I am just putting some kind of restrictions on the number of valid hash, not these. So therefore, this is called difficulty level. If I increase the difficulty level, what I have to say? I have to increase the zeros or decrease the zeros if I want to increase the difficulty level. For example, if I say that, okay, you have to get 100 zeros, or if I say that, no, you have to get 70 zeros. So which one is more difficult? 100 zeros or 70 zeros? Of course, 100 zeros. So if I increase the number of zeros, of course, it will be more difficult to get. You see? If I say that 3 zeros, okay, 4 possibilities are there. If I say that 3 zeros, sorry, if I say 4 zeros, then only 2 possibilities are there. So getting these 2 possible hash values really difficult. So therefore, I can vary this difficulty level by changing the number of zeros that I want in the final hash. So you see that these x I can change. So in this block, you can change the nonce value to try again and again. So first you compute, you take one nonce value, you do not get 100 zeros, change the nonce value, then you keep trying and suddenly you can get success. So there is a nonce. After you get success, that nonce value you have to put in the block as the miner. So now here is the example. Suppose this is the blockchain already you have and you are acting as miner. So what you have done, you have created one new block. This is the new block. And now you have to try with all possible nonce. So initially you have 0 nonce and you get hash. No, this is not having required number of zeros. And you keep trying. You change the nonce value. You change the nonce value. And if you are not successful, because nonce value can be of 32 bits, so 2 to the power 32 possible nonce values can be there. But if you are not successful, what you can do, you can change something here also. You can understand these are the transactions that you have considered in the block. But if those transactions can be created by other participants in the network, right? So these are the transactions. As miner, I can listen lot of transactions created by some others, and I can create this block considering all those transactions. But this is one special kind of transactions that I can create from my side as miner. I think there is some noise, maybe some, yeah, you can mute your mic maybe. Okay, thank you. So here you can understand, I have considered as miner, I have considered other transactions, of course, but I have created a new transaction from my side. And in this transaction, I can change the values also, some random value also, and that will also help me to get the required number of, zeros at the beginning of hash. Look, I'm changing this value, and finally I'm successful. Finally, I am successful with this nonce value and with this random value in this transaction. And when I am successful, what I'll do? As miner, I am successful. So I will add this block to my blockchain copy. Look, this is the previous hash pointer. The hash of the previous block will be there. So this is acting as the previous hash pointer. So that also is the part of the metadata. So all these are metadata. So this is the hash value of the current block. This is the transactions are being constructed in the form of market tree, that is a root, and this is the hash of the previous. So these are metadata and these are the actual transactions. So this is the block. So now if I am successful as miner, I will add this block to my blockchain copy, and then what I'll do? Okay, so one thing before proceeding, let me tell you that as I mentioned that this is the new block, this is the new transaction that I have created. This new transaction here, I have to mention some amount. And this amount will be my cryptocurrency. So I am allowed to create one new transaction where I am mentioning, please give me this amount of money to myself as the reward. And currently this reward is fixed. So in Bitcoin, if you can successfully create a block as miner, then you will get 6.25 at this current date. Last year it was 12 Bitcoin, 12.5 Bitcoins. So you know that every 4 years it is getting half. Initially the reward was 50 Bitcoin. After that 4 years, 25. After 4 years, it becomes 12.5. And now this year onward, for this now 4 years, it will be 6.25. So this 6.25 will be a reward you can claim because you are successful in block creation. And some other money you can also get from here, from other transaction, because whenever other transactions can also give some kind of tip, because you are actually including their transactions in the blockchain as a miner. So you are doing some kind of hard work. No? So that's why they can give some kind of tip, some fraction of Bitcoin as the tip. So those will be called transaction fees. So together, all this money you have to include in the Coinbase transaction. So this is called Coinbase transaction, and this is your money. And this is the way the Bitcoin or first cryptocurrency will be created. Bitcoin will be created. Okay. And now you can use those money. I mean, if I am acting as miner, I get these transactions reward. Then I have a lot of Bitcoins. I mean, 6.25 plus transactions fees. Then I can make whatever transactions I want. I can send it to my friends. Well, so after this block creation is successful, I mean, the miner is successful in creating this block with required number of zeros at the beginning, then what miner will do? Miner will add the block to his blockchain, as well as miner also will broadcast this block into the network. Broadcasting means miner is actually informing all other participants that, look, this is the block I have created, and I'm successful in creating the valid block. I mean, I have got the required number of zeros, and this is the information, detailed information. Please, you also include that block to your blockchain copy. So this way, every participant in the network will add this block to their blockchain copy. And this is a consensus algorithm. I mean, all the participants in the network have agreed to accept this new block created by the miner XYZ, for example. And this way it works. So therefore, what are the steps? First, join the network, listen the transactions. As normal participants, normal user, you can also validate the transactions that you are listening, because validation can be done by anyone, whether the transaction is valid or wrong, whatever you are listening. Then either you can, if you are acting as miner, then assemble a new valid block, finding the correct nonce value, and then broadcast it to the network, and everyone will accept that one. So you will get some reward. And if you are not acting as miner, you also listen for new blocks, and whenever other miners are proposing that, you just check and add it to your blockchain copy. So these are the steps to follow. Okay, so as I already mentioned, that if I increase the restrictions that have been put, that you have to have required number of zeros at the beginning of the block hash, then only you are successful in mining process. So because you have to compute the hash again and again by changing the nonce value, so this is called proof of work. This is called proof of work. And now here you can understand, if the number of zeros increased, so it means that the difficulty level also will increase. So when I talk about 2 zeros, you can find these are the valid hash. When I talk about 3 zeros, only these are the valid hash. So probability of getting the valid hash will decrease. So difficulty level will increase. So in Bitcoin, what happens that every 2 weeks, so today there is one difficulty level, but after 2 weeks, the difficulty level will be increased. Why there is a change of difficulty level in Bitcoin? So normally in Bitcoin, what happens? It is decided at the beginning that whenever in the Bitcoin, there is also a blockchain, right? Bitcoin is based on blockchain. So of course there is a blockchain. So in Bitcoin, it was decided that the gap between two blocks will be 10 minutes. So suppose now one block is being added in the network by all participants, proposed by a miner, and next block will be added after 10 minutes on an average. So now what will happen, since over time lot of people are joining in the network and lot of people are participating in the mining process. Mining process means that they are creating the block, they are solving the puzzle by changing the nonce values, and if they are successful, they are proposing the block and they are getting reward. So you can understand the reward value is 1 Bitcoin is equal to 28 lakh today. So you can understand if 6.25 Bitcoin means too much amount. So therefore, a lot of people will be attracted towards doing this mining process. So therefore, you can find that a lot of people are joining over time and they are investing their hardware, computation power into the network. So you can understand that over time, as time passes by, lot of computation power, the computation power also increasing. So if computation power increasing, then more blocks will be proposed. So if more blocks will be proposed, the gap between two blocks will be reduced. The gap between two blocks will be reduced. To maintain the gap between two blocks 10 minutes, difficulty level also will be increased. If I keep the same difficulty level, since computation power increasing, the gap between two blocks will be decreasing. But if I want to keep, the gap to 10 minutes fixed, so computation power increasing, so I have to increase the difficulty level. Okay, that's the main goal. So here you can find the red color saying that difficulty level is increasing. And now the blue color is saying that what is the gap between two blocks. You see the gap between two blocks is decreasing because more number of people are now doing mining and they are investing their hardware, computation power. So when the gap between two blocks decreasing and now suddenly the difficulty level will be increased, so thereby the gap between two blocks will become 10 minutes. Again the gap between two blocks decreasing. After 2 weeks again the difficulty level will be increased and then the gap between two blocks will be 10 minutes. So again decreasing. So 2 weeks observation period is maintained, and after 2 weeks, every 2 weeks the difficulty level will be varied. And you can understand, since reward means lot of Bitcoin market, Bitcoin prices, market price is very high, so a lot of people are really interested to doing this mining process. So therefore you can understand initially although difficulty level was too low, that's why CPU with simple computer it was possible, but over time, even today, FPGA GPU won't be enough to get the valid block. If I want to create a valid block with transactions, I will do a computation of hash computation, and if I get a required number of zeros, then I am successful, right? This puzzle solving, it is not possible using even GPU also. So therefore, today, you can understand very application specific integrated circuits are designed, developed only keeping in mind the mining of cryptocurrency. And even as simple, since as individual, my computation power is very low, right? So I cannot participate. I never can be able to do mining process. So therefore, what is the proposal that you can create a mining pool? 10 people together can create a mining pool where all the individual 10 people will do the, their computation power can be combined together to create a mining pool. So even if I am individual, I have low computation power, but as a part of the pool, the total computation power of the pool can be comparable. So mining, you can find a lot of mining pools today. Now finally, I can conclude that, okay, so here you can understand that today a lot of people are there in the Bitcoin network, for example. So its ecosystem is very large, very healthy. So therefore, of course, when the ecosystem will be large, you can understand lot of honest people will be there. Lot of honest people will be there because the success of this network, the success of this system depends on how many honest people are there. And the computation power of the honest people. So therefore, if ecosystem is very large, okay, there is, I think you can mute your mic, please. Okay, so then you can understand that if the number of people in the network increases, then a lot of honest people will be the part of the system, and they will have a lot of, I mean, majority of the people will be honest, and they have majority of the computation power. So in this case, the security of the network system will be will increase, and if the security of the system increases, then you can understand the market value of the cryptocurrency also will increase, and if the market value of the cryptocurrency increases, then it will attract more people also to increase the. Okay, so now here this is very interesting fact. I will take madam, how much I have time? I think 1:15, right? Okay, so maybe I have 15 or 20 minutes more. So let me go through very quickly. So here, okay, we understood, I hope that you understood at the high level completely, the working principles of blockchain technology and how they are working in case of cryptocurrency. For example, Bitcoin. But if we look at other kinds of platform, I mean, Ethereum. So Ether is another cryptocurrency. Ether is another cryptocurrency. And this is second most popular cryptocurrency. But if we compare the market price, here is the difference. But today, actually, actually, this is the old data. So if you compare, if it is, for example, 30,000 somehow, it is today, I think it's around more than 1,000 USD. Okay, but still, there is a huge gap in the market price. But the corresponding, but what is the difference between Bitcoin and Ethereum? So Bitcoin only for cryptocurrency, but Ethereum, this is another blockchain platform that is having a cryptocurrency that is called Ether, but it's not only the cryptocurrency. Ethereum is something more than that. Clear? So Bitcoin is only for cryptocurrency, but Ethereum is for cryptocurrency as well as something more than that. So therefore, if you compare that in Bitcoin, it's like a simple calculator. And as I mentioned, that when I create a new transaction, I have to mention something in my transaction in the scripting language that is called Bitcoin scripting language. I have to mention something. I have to write something in the transaction which will help all the participants to verify whether my transaction is valid or not. But this language is very simple kind of language, and this language does not support loop, I mean while loop, for loop, does not support any kind of recursive function. So I mean this language is not Turing complete. It cannot express all this computation, but it is very simple form. So I can compare Bitcoin as a simple calculator. So now the question is that today, can we have this kind of smart device? Here we can have, calculator as well as some other applications also, right? If I compare Bitcoin as simple calculator, only it can calculate. But here I have calculator as well as something more than that. So therefore, Ethereum, you can understand this is something like that. So in Ethereum, it supports cryptocurrency that is called Ether. Perfect. But the good thing is that Ethereum can also support a programming language, and using that programming language, I can write my application. So I can write my application, and that application I can put in the blockchain. In Bitcoin, I can only put transaction information in the Bitcoin, nothing else. But when I talk about Ethereum, there I can put transaction information as well as I can also put some kind of program code. And when I have the ability to write some program code, you can understand that I can create some kind of applications. So therefore, Ethereum supports some kind of, like C, C++, Java, JavaScript, Python. So like that kind of programming language it supports. And using that programming language, so one very popular programming language is Solidity programming language. So using this programming language, you can create your own small program. And those program you can keep in the blockchain and you can also execute. So therefore, you can those kind of programs called smart contract. So whenever you can create this kind of smart contract and you can keep this kind of smart contract in the blockchain. So this made blockchain so powerful that blockchain can be applicable in various applications like healthcare, like asset transfer, like food supply chain, like e-commerce, like insurance, everywhere. And you can act as, this platform will act as some distributed platform where some kind of applications is executing. So therefore, smart contract is a computer program executed in a blockchain. So very simply that I think, so for example, if the code is in the blockchain, suppose this is the blockchain, okay, this is one block and this is another block and this is the part of the blockchain. So two blocks I have shown here, and you can understand in the block I can also keep some kind of program code, and now I can also execute the program code. Okay, so this kind of facilities are there in the blockchain. And when I write this code, I will write this code in the high level, but when I put in the blockchain, I have to compile it. After compilation, I'll get some kind of bytecode. In Java, you know bytecode, similar kind of bytecode you get here, and that bytecode will be part of the blockchain. Now, what is the benefit of these things? So I think if I unshare, is it visible? If I open a paint, is it visible?
Yes, sir.
Okay. So what will happen? Suppose a lot of participants are there and they are connected in a blockchain, I mean peer-to-peer, distributed peer-to-peer network, and everyone is maintaining some kind of blockchain. Right. So this is being, I mean, this copy will be with everyone. Okay. So this is a copy that will be with everyone. Now, what will happen if you find that there is a one program? So I can write that this is the program. I have put some program in the smart contract. Program is stored in the blockchain. So this is the program P in the blockchain. So every blockchain copy should have that program, and this is nothing but P is nothing but smart contract, right? Smart contract. Now what will happen? Anyone, suppose you can also execute the smart contract here. You can execute the program here on your own machine. So you have to install some software, and that is some virtual machine. It will create some virtual machine. On the virtual machine, it can be executed. So once you execute your smart contract on your machine, then that actually what happens, it's not actually happens this way. Actually, it happens that suppose you want to execute some program. Suppose you want to execute this program, so you have to make a transaction. You have to make a transaction saying that I want to execute this function. So these transactions will be broadcasted into the network, similar to, I mean, cryptocurrency transaction. Suppose you want to transfer some money from you to your friend. So that is also another transaction that you have to broadcast into the network. So similarly, if you want to execute some program in your blockchain, the smart contract, you have to make a transaction. So similarly, many transactions is being broadcasted. And suppose this node is acting as minor. Suppose this node is acting as the minor. So this node will consider all these transactions together and will create a block. And then it will, at this block, it will propose the block, and finally this block will be added to all the blockchain copies. So this block will be added to this blockchain copy. This will be added to the blockchain copy. Sorry. Added to the blockchain copy. Every blockchain copy, it will be added. Okay. So now you can understand that when this node has created this block, in this block, there is one transaction saying that you want to execute the program P. You want to execute the program smart contract P. So now before adding this, actually this program will be executed. This program will be executed. I mean, the transaction will be executed. Similarly, when this block will be added by you, here the transaction is there, right? The transaction saying that I want to execute this program. So you also will execute this program. You also will execute this program. So everyone will execute the program on their own copy. So you understand? So suppose I am now giving one example. Suppose this is a seller and this is the buyer. And suppose this buyer wants to buy something from this seller. So in this case, you can understand there is one smart contract P in the blockchain, and this smart contract will help in this buying selling procedure. Let's see. So this is one example. What is happening? In this smart contract, this is program code where there is a lot of functions. You know, C functions, Java functions. In the program, you can write a lot of functions. So there are so many functions. So what will happen? The buyer will send one transaction saying that I want to execute the function which will send my request. And then after execution, that function will send a request to seller. And then seller will execute some function that will inform the code that he wants to sell the product. And then smart contract automatically will inform buyer that please pay this amount of money. Then buyer will execute the transactions. I mean, I can mention it here. So what will happen? There are a lot of functions. So buyer will execute some function that I want to buy something. Then seller will execute the function saying that I want to sell the product, but this is the amount. Then buyer will pay the money. But remember, when buyer will pay the money, that money will remain with the smart contract code, because in the smart contract code also the cryptocurrency can be stored. So when buyer will pay the money will be stored by the cryptocurrency. By the smart contract. It will not be given to the seller at this point. And after that, when the seller will dispatch the product, then that money will be given back to the seller. So in this case, when the product will be given to the buyer, then buyer will inform the code, and the code then will transfer that money which was on hold with the smart contract to seller's account. So you can understand this is a very simple example that will tell that I can replace the Amazon, I can replace Flipkart. There is no need of third party. I can replace all the third party and the code automatically will execute their functionalities to achieve the goals. So this is the power of smart contract. And this the distributed execution, you see, the execution is happening in a distributed manner, but whatever execution happening, that is being reflected everywhere. I mean, the same state reflection happening all over the network in all blockchain copies. Okay, so although this 1.5 hours may not be enough to describe all these things, but my intention is to give just high level overview to have you interest in this blockchain technology. But you see, whatever execution will happen on this smart contract or on this smart contract by seller or by a buyer, so everything actually it will happen through the transaction. So they have to initiate the transaction. That transactions will be considered by the miner, and the miner will execute those transactions over the program. And similarly, when the block will be added by the buyer and seller, the buyer and seller also will execute those program on their own machine. Okay. So now, overall architecture is that, at the low level, you can find that there is the actual blockchain where the actual information will be stored. On top of that, there is the network layer where the peer-to-peer distributed network is being created. On top of that, you have consensus layer where the mining process will happen, where the new block will be added to all blockchain copies. I mean, the miner will create the new block, will broadcast into the network, and everyone will add the block into their blockchain copy. That is the consensus. And the consensus in Bitcoin that I have shown, it's done through proof of work. If the miner can show that I have done enough work, then only other people will accept it. So required number of zeros, he has to create the hash for the block. So he has to compute the hash value again and again for the block he has created. If he is successful, then only he will propose into the network and all the network nodes will accept the block. So that is the consensus. And on top of that, once incentive layer. So miner, if I am successful in adding the block, I will get some kind of reward. Right? Those are the incentive. Incentive can be given to various participants to enable to make them honest, to behave honestly in the network. And on top of that, you have smart contract. I mean, that I mentioned, I can replace the Amazon, Flipkart by smart contract code. I can replace Ola, Uber by smart contract code. I can replace all the insurance companies by smart contract code. I can replace all the, so everything can be replaced by the smart contract code, and so whatever functionalities the insurance company was doing, that can be done by the smart contract. And that will remove all the third parties actually, and bring lot of trust in the system. And finally, you can have your applications. I mean, you can have medical application, you can have smart agriculture application, you can have asset transfer application, whatever. Okay, if you go to the document proposed by Niti Aayog, you can find a nice use case. And there they are showing that when you go for the blockchain, when you do not go for the blockchain, and in the blockchain there will be public private kind of blockchains that you will get information in detail in the next session. And so whether you should go for public blockchain or private blockchain, you can get a very clear direction. For example, Bitcoin, this is public because you don't need any kind of permission, for example. This is the last example that I can mention here before concluding my session. Yeah. So here you can find that how very nice, Vitalik Buterin, he is the actually introducer of Ethereum. He's just 19 years old when he introduced that Ethereum, and now Ethereum is really popular. So this is very interesting quote that instead of putting the taxi driver out of a job, blockchain can put Uber out of a job and lets the taxi driver work with customers directly. Very nice. So what happens? For example, there is a rider, there is driver, and there is the blockchain, and there will be the smart contract code in the blockchain. So now rider can execute the smart contract code saying that I want to travel from this place to this place, and I want this kind of card, and this is the number of passengers. And then smart contract automatically will store all this information and will, there is all the driver's information. Based on that, driver will be assigned and will be sent a notification to the driver. Then driver will accept the ride, and then the rider information will be given back to the driver. And then driver will do what the actual task, and after that the payment can be done through the smart contract, through cryptocurrency, and finally the rating can be done, and driver also can give the rating to the rider. So everything will be done automatically by invoking some kind of functions in the smart contract. So you can find there is no centralized authority, there is no Ola Uber, but there can be so many different drivers, there can be so many different riders, and smart contract automatically will do everything based on the logic implemented in the smart contract. So smart contract actually encodes the business logic in the form of automation. So because of interest of time, I am skipping all these things. Actually, this is the how Bitcoin transactions actually happen. So I can skip this part at this point. Okay, so with this, I want to conclude this session. Thank you so much. So if you have any questions, feel free to ask me.
Thank you, sir. Can you hear my voice?
Yes, I can hear you. Yeah.
Okay, thank you, sir. Thank you very much. Dear participants, any queries from this session? Participants? Okay, sir.
Okay, thank you.
Thank you. Thank you for in handling this session for in busy schedule.
Thank you so much. Thank you for your invitation. Again, thanks all participants. Thank you.
Thank you, sir.